Hello everyone, this is Jason. We're looking in Algebra 2 and we're trying to find the inverse of a 2 by 2 matrix. So we're going to be given the matrix A and with the entries A, B, C, D, and we want to know how to find its inverse. Well, you know the inverse, if you multiply the original matrix and its inverse, you'll get the identity matrix. So in this instance, we're going to use this little rule, is that the inverse equals 1 over the determinant times, and then we have to do a little change to this matrix and just kind of remember this change. A and D are going to swap places, so we're going to have D here and A here, and then these two just change signs. So that's going to be the rule for the identity matrix or for the inverse matrix. And here's another rule: the inverse only exists if the determinant does not equal 0. So let's simplify this so we know exactly what we're doing here. This is 1 over AD minus BC. And then we're going to multiply that by D, opposite of B, opposite of C, and then A. So that's going to be our matrix rule. And then, AD minus BC can't equal 0 because we can't divide by 0. All right, so let's take a look at our first example. So here's our first example. This is our matrix A. So to find the inverse, we're going to do 1 over AD minus BC. And then we're going to swap these two. So we're going to put negative 11 there. We're going to put 1 there. We're going to change these signs. So we're going to get 9 and negative 1. All right, so what's AD minus BC? AD is 1 times negative 11, which is negative 11, minus negative 9 times 1 is negative 9. And then we're going to have our matrix. And then this is going to equal 1 over, and we'll add these, so that'll be 1 over negative 2 times negative 11, negative 1, 9, 1. This becomes scalar multiplication now, so we're just going to multiply these out. So that's going to give us 11 halves, 1 half, negative 9 halves, and negative 1 half is our inverse matrix. So that's going to be the inverse of our original matrix. And now, how do you know Jason's right? Well, if we multiply these, if we multiply A times the identity or the inverse matrix, we should get the identity matrix. So let's see if it happens. Now, I want you to understand this, that in matrices, commutative property doesn't always apply. So A times A inverse is going to equal the identity matrix, but it's not always true that the inverse times the original equals that. It's not always true. So don't think that you can multiply it either way. You have to multiply it this way to make sure you get the right answer. All right, so let's take a look. We're going to do this. This will be the only time I do this, because I want you to know from then on that, yep, that works, as long as I do the math right. But now this is a good way to check. So we're going to multiply these two matrices together. And hopefully we'll get the identity matrix. If not, we know we've done something wrong. All right, so now remember, to do the product, we're going to multiply first row times first column, first row times second column, and then do the same thing for the second row. So first row times first column, it's going to be 1 times 11 halves, so that's 11 halves. 1 times negative 9 halves, so plus negative 9 halves. Okay, that's going to be our first entry. We've got 1 times a half, which is a half. 1 times negative 1 half, so plus negative 1 half. Second row, first column, we got negative 9 times 11 over 2 is negative 99 over 2. Plus negative 11 times negative 9 over 2 is positive 99 over 2. And then second row, second column, We got negative 9 halves times 1 half is negative 9 halves, plus negative 11 times negative 1 half is negative, or positive, excuse me, 11 over 2. And if we work this out, 11 halves plus 9 halves is 2 over 2, which is 1. 1 half plus negative 1 half is 0. Negative 99 over 2 plus 99 over 2 is 0. And then negative 9 over 2 plus positive 11 over 2 is 2 over 2, which is 1. So we got the identity matrix. So that's the process for a 2x2 matrix. And then you can check, make sure you got the right answer. Now let's take a look at this one. So here is our identity matrix, or excuse me, our A matrix. We want to find the inverse. So the inverse is 1 over the determinant AD minus BC. And then we're going to swap these variables. We got 7, 8, negative 8. And then we're going to change these signs. Okay, so let's find that determinant first. 1 over AD, which is negative 56, minus negative 7 times negative 8, which is negative 56. Oh, look at that. We got negative 56 plus 56, which is 1 over 0. This will not, NOT, not HAT, will not have an inverse. So I hope this helps you find the inverse of a 2x2 matrix. If not, please let me know and I'll find you some additional resources to help you.